Opposed, you have the inductance. What does the inductance do? Inductance is basically like the mass of a body. Now I'm actually considering analogs. It isn't the mass of anything, an analog. It is the electrical analog of mass. What does mass do? Mass is a measure of inertia. So you need a force to accelerate the body or change its velocity, change its momentum. The reason, because it has a mass. Because of the mass, because of the inertia, there is a force needed, or there would not be any force needed to change the momentum and stuff. In a similar way, you need a voltage to change the current as long as you have an inductor in that. That is the work of inductance. Now the capacitance, what does it do? It stores the charge. Now the capacitance stores the charge, voltage across a capacitance, that is Q over C, the charge over capacitance. Now you see, impedance is a combination of these three elements: the resistance, the inductance, and the capacitance. When you combine them, you get what you call impedance. It isn't as simple as the square root of R squared plus L squared plus C squared. No, it's not that. You will have to consider terms that are called inductive reactance and inductive capacitance. You find them, which actually depends on how fast the voltage is oscillating. Always and always you need an oscillating voltage there, an oscillating voltage, a changing voltage there. Now why do you need a changing voltage? Because if you have a steady voltage, then you have a steady current. If you have a steady current, then you know there is no work of inductance in that. If you have a steady current, there is no work of inductance or capacitance in that. All that works is clearly in here, the resistance. So you need an oscillating over here. What voltage that will give rise to an oscillating current? So depending on the oscillation or the frequency of oscillation, angular frequency of oscillation of the voltage and thus the current, you will have the inductive reactance and capacitance. Now, combining the inductive reactance, actually the difference between the inductive reactance and inductive capacitive reactance. Sorry, I was finding the terms wrong. That is the inductive reactance and the capacitive reactance. So by finding the difference between the two, squaring it and adding it to the resistance squared, then you get the root of this term. That is what you call the impedance of this particular thing. I'm not really that good with names and stuff. What matters is the concept. So you get this. Now this impedance, what does it mean physically? What does impedance mean physically? To understand what impedance mean physically, consider a harmonic oscillator. Alright, we consider a harmonic oscillator. The net force on the harmonic oscillator will be given the mass of the oscillator times